Hello learners, welcome to Unacademy Ascend YouTube channel. This is Umamaheswara Rao. In this 2 months crash course, today I will be discussing discrete probability distributions. Discrete probability distributions. Discrete probability distributions means binomial and Poisson. First, I would like to explain binomial distribution. The probability mass function of binomial distribution. The probability mass function of binomial distribution is given by P of x equal to NCx P power x Q power n minus x. X takes values 0, 1, 2 and so on n, where n represents n is number of trials, x is the random variable, P is probability of success of the random variable, Q represents probability of failure of the random variable. Probability of success plus probability of failure equal to 1. The probability mass function of binomial distribution is given by P of x equal to NCx P power x Q power n minus x. X takes values 0, 1, 2 and so on n. It is discrete probability distributions. Discrete probability distribution is nothing but random variable x takes countable values. In binomial distribution, x takes values 0, 1, 2 and so on n, countable. So here n represents values 0, 1, 2 and so on n, countable. Number of trials, x is the random variable, p is probability of success of the random variable, q is probability of failure of the random variable. Sum of probability of success plus failure is always 1. Now, mean. Binomial mean is given by NP. Binomial variance is given by NPQ. The mean of binomial distribution is NP and variance of binomial distribution is NPQ. Now, when we have to apply binomial distribution, any experiment is repeatedly applied, possible outcomes are only two, either success or failure, then we are going to prefer binomial distribution. For example, a dice is rolled 3 times. A dice the probability that exactly one odd number, exactly one odd number turns up among one odd number turns up among the three outcomes is first option 1 by 6, 3 by 8, 1 by 8, 1 by 2. Yeah, here a dice is rolled 3 times. Same experiment, throwing of dice 3 times is number of times an experiment is repeated 3 times. So n represents number of times an experiment is repeated. So n is equal to 3. Now, problem is designed on probability that exactly one odd number turns up. So getting of odd number is random variable x. Random variable x counts getting of odd number. How many times you got odd number, that is counted by random variable x. Now P is probability of success of the random variable. You have defined here random variable x counts number of times odd number is appeared. That's why probability of getting odd number is given by P. So 3 by 6. There are 3 odd numbers 1, 3, 5 out of 1, 2, 3, 4, 5, 6. That's why 3 by 6. 3 by 6 is nothing but 1 by 2. Now Q is probability of getting even number, that is nothing but 1 minus 1 by 2, that is 1 by 2. We have to find out probability of getting exactly one odd number. So exactly one odd number. So random variable x counts odd numbers. That's why exactly one odd number means probability of x equal to 1. In binomial distribution, probability of x is given by ncx. So here nc1, p power 1, q power n minus 1. Substitute the values of npq here. 3c1, 1 by 2 whole power 1, 1 by 2 whole power 3 minus 1. Now 3c1 is 3, 1 by 2 whole power 1 into 1 by 2 whole square is 1 by 8, so 3 by 8. Probability of getting exactly one odd number is 3 by 8. Next, next column, a coin is tossed independently. A coin is tossed independently 4 times. A coin is tossed independently 4 times. The probability of the event, the number of times heads shows up is more than the number of times tails shows up is first option 1 by 16, second option 1 by 8, third option 1 by 4, fourth option 5 by 16. Fourth option 5 by 16. Now here a coin is tossed independently 4 times. A coin is tossed independently 4 times. So n represents number of trials. So here n is equal to 4. Now x counts number of heads. Whenever you toss coin, x counts number of heads appear. Now if x is defined as number of heads, p is equal to probability of getting head 1 by 2. So q is equal to 1 minus 1 by 2, that is 1 by 2. Now in this problem we have to find out the probability that number of heads are more than number of tails. Suppose number of heads are 3, number of tails are 1. Suppose number of heads are 4, number of tails are 0, because total number of tails are 4. That's why. So number of heads are more than number of tails means number of heads are 3, number of tails are 1, or number of heads are 4, number of tails are 0. These are the two cases. We have to calculate probability of getting number of heads are 3, probability of getting number of heads are 4. Either number of heads are 3 or number of heads are 4. Two cases. Now either number of heads are 3 or number of heads are 4. Two cases. Now probability of x is equal to 3 or x is equal to 4. Now nc3 p power 3 q power n minus 3 or nc4 p power 4 q power n minus 4. Now substitute the values of n, p, q. N is 4. 4c3 1 by 2 whole power 3, 1 by 2 whole power 1. 4c4 1 by 2 whole power 4, 1 by 2 whole power 4 minus 4. Now 4c3 is 4, 1 by 2 whole power 4 is 16, 4 by 16 plus 1 by 16, that is 5 by 16. The required probability is 5 by 16. Understood? Next column. An unbiased coin is tossed. An unbiased coin is tossed 5 times. The outcome of each toss is either head or tail. Either head or tail. the probability of getting at least one head is, the probability of getting at least one head is option A 1 by 32, 13 by 32, 16 by 32, 31 by 32. Now a coin is tossed 5 times, that's why number of trials are 5. X counts number of heads. P probability of getting head 1 by 2. Q 1 minus 1 by 2, that is 1 by 2. Now the probability of getting at least one head is, at least one head, probability of getting at least one head is, that is nothing but probability of x greater than or equal to 1. X greater than or equal to 1 is nothing but 1 minus probability of x less than 1. At least 1, so minimum 1, right? That's why 1 minus probability of x less than 1. 1 minus probability of x less than 1 is nothing but 1 minus, it is discrete, that's why probability of x equal to, it is discrete, that's why probability of x equal to 0. That can be written as 1 minus probability of x equal to 0 is nc0 p power 0 q power n minus 0. 1 minus 5c0 1 by 2 whole power 0 1 by 2 whole power 5 minus 0, that is 1 minus 1 by 32, that is 31 by 32. The required probability is 31 by 32. So correct answer is 31 by 32. Next problem. In an experiment, positive and negative, positive and negative values are equally likely to occur. The probability of obtaining at most one negative value in 5 trials is at most 6 by 32. In this problem, the keyword is at most. At most one negative value. Here, n represents number of trials, so n is equal to 5. X counts number of times negative value is appeared. X counts negative value. Now P, probability of getting negative value. probability of getting negative value is 1 by 2 because the positive value and negative value are equally likely in a random experiment. That is mentioned in the data. Both are equally likely. Therefore, probability of getting negative value is 50%. Probability of getting positive value is also 50%. That's why Q is 1 minus 1 by 2, that is 1 by 2. Now, we have to find out probability of getting at most one negative value. At most one negative value. At most one negative value means x less than or equal to 1. At least means x greater than or equal to 1. It is at most. That's why x less than or equal to 1. That is nothing but probability of x is equal to 0 plus probability of x equal to 1. Probability of x equal to 0 is nc0 p power 0 q power n minus 0. X equal to 1 is nc1 p power 1 q power n minus 1. N is 5. 5c0 1 by 2 whole power 0 1 by 2 whole power 5. 5c1 1 by 2 whole power 1 1 by 2 whole power 5 minus 1. Now this is 1 by 32 plus 5 by 32, that is 6 by 32. One by 32 plus 5 by 32 is 6 by 32. So here correct answer is 6 by 32. Next column. The unbiased coin is tossed an infinite number of times. The probability that the fourth head appears at the 10th toss is, first option 0.067, 0.073, 0.082, 0.091. An unbiased coin is tossed infinite number of times. The probability that the fourth head appears at the 10th toss. Fourth head appears at the 10th toss. So here fourth head appears at the 10th toss means 10th toss we have to get head, but that head should be fourth head. When we can say that head is fourth head? If you are already got 3 heads, exactly 3 heads in 9 trials, okay, you can say that whatever head you are going to get in 10th trial will be the fourth head. That's why in 9 trials we have to calculate. In 9 trials we have to get exactly 3 heads. So first we have to calculate probability of getting 3 heads, exactly 3 heads in 9 trials. So here n is 9, p probability of getting head 1 by 2, q 1 by 2. So we have to calculate probability of getting exactly 3 heads in 9 trials and 1 head in 10th trial. 1 head in 10th trial. Now probability of x equal to 3 is nc3 p power 3 q power n minus 3 and means multiplication. Head. Now n is 9. 9c3 1 by 2 whole power 3 1 by 2 whole power 9 minus 3 6 into 1 by 2. That is 9c3 into 1 by 2 whole power 10. 9c3 is 84 by 1024. That is 0.082. That is the required probability. Next one. Another discrete probability distribution is Poisson distribution. Now, Poisson distribution. Poisson distribution. The probability mass function of Poisson distribution is given by P of x equal to e power minus lambda into lambda power x by x factorial. X takes values 0, 1, 2 and so on, whose mean is lambda, whose variance is also lambda. Mean is lambda and variance is also lambda. Now, note, Poisson distribution is the limiting case of binomial distribution. Poisson distribution is the limiting case of binomial distribution. That is, meaning of that statement is, if number of trials n is large, if n is large and p is very, very small, and p is very, very small, then Poisson mean lambda and binomial mean np both are equal. Whenever you found that n is large and p is very, very small, you can understand that the problem is designed on Poisson distribution. Whenever n is large and p is very, very small, instead of applying binomial, better to go for Poisson distribution. Problem. A traffic office imposes on an average 5 number of penalties daily on traffic violators. Assume that the number of penalties, assume that the number of penalties on different days are independent and follows Poisson distribution. Follows Poisson distribution. The probability that there will be less than 4 penalties in a day is 4 penalties in a day is. Now here on and average traffic office imposes 5 number of penalties daily. That's why we have to find out the probability that there will be a less than 4 penalties in a day. Given that on and average traffic office imposes 5 number of penalties daily on traffic violators. That's why lambda value is 5. Lambda is equal to 5. X counts number of penalties imposed by the traffic office. So here we have to calculate probability that the number of penalties are less than 4 on a day. So x less than 4 is nothing but probability of x equal to 0, x is equal to 1, x is equal to 2, x is equal to 3. Because less than 4 penalties in a day. Now in Poisson distribution, probability of x is e power minus lambda into lambda power x by x factorial. Here x value 0, that's why lambda power 0 by 0 factorial. Probability of x equal to 1 is e power minus lambda into lambda power 1 by 1 factorial. X equal to 2 is e power minus lambda into lambda square by 2 factorial. E power minus lambda into lambda power 3 by 3 factorial. Now if you take e power minus lambda common, e power minus lambda of 1 plus lambda square by 2 plus lambda cube by 6. Now substituting the value of lambda equal to 5 in this, we get e power minus 5 of 1 plus 5 plus 25 by 2 plus 125 by 6. Now this can be written as e power minus 5 of 31 minute. E power minus 5 of LCM is 6. 6 6 yeah 36 plus 2 3, so 25 3 is 75 plus 125. Now 125 plus 75, 200, 200 plus 36, 236. 236 by 6 into e power minus 5. By simplifying this, we get 0.265. The required probability is 0.265. Next problem. An observer counts 240 vehicles per hour at a specific highway location. Assume that the vehicle arrival at the location is Poisson distributed. The probability of having one vehicle arriving over a 30-second time interval is. An observer counts 240 vehicles per hour at a specific highway location. Assume that the vehicle arrival at the location is Poissonly distributed. The probability of having one vehicle arriving over a 30-second time interval is. Observe here, the data is given as on an average 240 vehicles are crossing the point per 1 hour. But in the question, they have questioned the probability of having one vehicle, x counts number of vehicles, so x is equal to 1, arriving over a 30-second time interval. So we have to calculate on an average how many vehicles are crossing in a 30-second time interval. So here on an average per 1 hour 240 vehicles are crossing. 1 hour is nothing but 60 minutes. 240 vehicles are crossing. So per 1 minute 4 vehicles. 1 minute is nothing but 60 seconds. 4 vehicles. For 60 seconds 4 vehicles means 30 seconds 2 vehicles. So on an average in 30-second time interval 2 vehicles are crossing. Therefore lambda is equal to 2. Lambda is equal to 2. Now x counts number of vehicles. X counts number of vehicles. Now probability of x is equal to 1. E power minus lambda into lambda power 1 by 1 factorial. So lambda value 2. 2 into e power minus 2. 2 by e square. 0.2706. The required probability is 0.2706. Next problem. The second movement of a Poisson distributed random variable is 2. The mean of the random variable is the second moment of the Poissonly distributed random variable is 2. The mean of the random variable is. So here given that the second moment means expectation of x square is 2. We have to find out expectation of x. So here random variable x follows Poisson distribution. So now in formula of variance of x is expectation of x square minus expectation of x whole square. The speciality of Poisson distribution is mean and variance of Poisson distribution is same, that is lambda. So lambda is equal to expectation of x square is 2, that is given in the data. Expectation of x is lambda whole square. So here lambda is equal to 2 minus lambda square, that is nothing but lambda square plus lambda continuation, lambda square plus lambda minus 2 equal to 0. You can factorize like this: lambda plus 2 multiplied with lambda minus 1 equal to 0. So lambda is equal to minus 2, lambda is equal to 1. In lambda equal to minus 2 and lambda equal to minus 1, lambda equal to 1 is considered, lambda equal to minus 2 is neglected. The reason is variance of x is always non-negative. That's why minus 2 is neglected, because in Poisson distribution mean equal to variance equal to lambda equal to 1 here in this problem, because 1 is considered. So mean and variance of Poisson distribution are same. Mean and variance of Poisson distribution is lambda. Here lambda value is 1. Understood? Next problem. If a random variable x has Poisson distribution with mean phi, then expected value of x plus 2 whole square is. So in this problem, lambda is 5. That is given in the data. We have to find out expected value of x plus 2 whole square. To calculate expected value of x plus 2 whole square, I am going to use the formula of variance. Variance of x is expectation of x square minus expectation of x whole square. In Poisson distribution, mean and variance are equal to lambda. So expectation of x square minus expectation of x whole square. Now, variance of x is 5 here because mean is 5. Mean and variance are same. That's why this is 5. Expectation of x square is unknown. 5 square. That is expectation of x square equal to 25 plus 5, that is 30. So expectation of x square is 30. Now we have to find out E of x plus 2 whole square. Expectation of x plus 2 whole square, that is x square plus 4x plus 4, that is expectation of x square plus expectation of 4x plus expectation of 4. E of x square is E of x square. Expectation of 4 into x is 4 into expectation of x. Expectation of 4 is 4. Now expectation of x square is 30. Just now we have calculated here. Expectation of x square is 30. Lambda value 5. That's why I am going to write E of x square is 30. E of x is 5 plus 4. So 30 plus 20 plus 4. That is 54. So here expectation of x plus 2 whole square is 54. Understood? I will be starting a course on engineering mathematics for GATE 2022. Course starts from 1st January 2021. Timings 6 p.m. to 8 p.m. Batch starts from 1st January 2021. Timings 6 p.m. to 8 p.m. which will be useful for mechanical engineering, electrical engineering, electronics and communication engineering, civil engineering, instrumentation engineering, chemical engineering. Unacademy also launches Evolve for GATE 2022 new batch starting from 28th December 2020 in mechanical engineering and electrical engineering and electronics and communication engineering and civil engineering. From 3rd semester onwards, you can begin your preparation for GATE and ESE with Unacademy. This is really a great opportunity for college going students. Unacademy also launches 2-year batch courses for GATE and ESE aspirants, putting together with excellent educators in each field. The entire syllabus for GATE and ESE will be covered in this program. Ascend batch for GATE 2023 in mechanical engineering, electrical engineering, electronics and communication engineering, and civil engineering. Get Unacademy subscription and learn from top educators using my referral code KUR75. In Plus courses, you have live classes, crash courses, weekly tests, separate doubt solving sessions, rank improvement batches in both English and Hindi medium. In Iconic subscription program, you have preparatory study material, personal coach, study planner, study booster sessions, personalized test analysis. These are the additional benefits in Iconic subscription. So whether it is Plus subscription or Iconic subscription, learn from top educators using my referral code KUR75. Use code KUR75 to avail 10% discount. Thank you.